Example 2, how long will it take for the money in an account that is compounded continuously at 4.25% to double? So a couple of things. First of all, when it says continuously, we automatically know they're using the PERT equation. But something very subtle and very important is the fact that they say it's doubling. The money is doubling. So the amount you end up with is going to be twice whatever you started with. All right, so that's something that you would need to know. You could plug in numbers right there if you wanted to and say the ending amount is 1 if the starting amount was 1/2 or any number you want as long as the end amount is double. But I'm going to do it like this. And so let's just say the ending amount right there is 2p. And the rate is 0.0425. And we want to know the time. So what happens here, if you set this up right, those p's, or whatever those numbers are going to cancel and give us 2 equals e to the 0.0425 t. So in order to get out of this, in order to solve this, you're going to do a natural log of both sides. You want to cancel out that e, you're going to do a natural log. So we do natural log of 2. Gives us about 0.693 or so. Is approximately equal to 0.0425 t. Now notice I'm going to leave that number in the calculator and I'm going to take that and divide that number by 0.0425 so that way I don't have to worry about the rounding. And I've got t is approximately equal to 16.3 years. So how long will it take? It's going to take about 16 years. Example 3, the projected world population in billions, t years after 2010 is given by the function, and I didn't give you the function, so let's do that now. F of t equals 6.947 e to the 0.00745 t. So that's your model, modeling the projected world population. Part A says, what will the world population be at the end of 2020? So they're wondering, they want to know the Y number basically, but at the end of 2020, they're saying that's 10 years after the start of 2010. So essentially we're just plugging in 10. F of 10 equals 6.947 times e to the 0.00745 times 10. Calculator question. I use parentheses around my exponent if I've got more than one number in there. 7.484. So we get about 7.484 billion. Remember, we're in billions. What will the world population be? About 7.5 billion. In what year will the world population reach 8 billion? So that's a Y number. So put that on the left side of your model. 8 equals 6.947 e to the 0.00745. T is what we're trying to find. So we're solving for t. We're going to have to isolate. Seems like that's what we always do. So divide by 6.947. So we get about 1.1516 e to the 0.00745 t. And then to get out of that, we're going to take a natural log of both sides to cancel out the e. So take a natural log of that answer and you won't have to worry about rounding. 0.14113 or so is approximately 0.0074, what was that, 5 t. And then lastly, of course, to isolate, we're going to divide. That number that's already on my screen by 0.00745. We get about 18.94 T is approximately, what was that? 18.94. And that was almost 19 years. So it's almost 19 years. It says in what year? So we have to go 19 years after 2010. That was the start. No, we wouldn't do 19, we'd do 18. Almost 19. It's going to be in the 18th year. So 2028. Sometime during the year 2028. Half-life is the amount of time it takes for a quantity that decays exponentially to become half its initial amount. Example 4, suppose 800 grams of a radioactive substance are present initially and 2.5 years later only 400 grams remain. So notice that's half as much as what we started. Determine the exponential function that models this decay. So remember from before, we still have that same y equals y0 e to the k t. That's going to work for growth or for decay. So if we look at this, what we ended up with was 400. What we started with was 800. E to the 2.5, well actually k would be first, but it doesn't really matter, I suppose. E to the k times 2.5 years. So for solving, we keep doing the same things over and over again, but divide by 800, and obviously that's going to be a half, or 0.5. There's your half-life. In order to get rid of the e, we're going to do a natural log of both sides. So natural log of 0.5 is negative 0.693 or so. That's approximately equal to 2.5k. And then, of course, if we continue to solve, we're going to divide by 2.5. So take that number. Notice I haven't rounded off. I'm going to divide by 2.5. I don't have to worry about rounding off. K is approximately negative 0.2773, let's say. So if I want to determine the function, I've got this model. I would have, go back and look at this. Okay, you would have y equals, the starting amount was 800, e to the negative 0.2773 t. Part B, how much of the substance will be present after 4 years? We'll just plug 4 into your formula. So we're going to see how much is there after 4 years. Plug in 4 years. 800 times e to the parentheses negative 0.2773 times 4, about 263.9. 263.9, what is this, grams? That's how much would be present after 4 years.